So for this graph, I have f of x, and then I have f double prime and f prime, and we're going to justify where maxes, mins, and zeros occur and how you can see them from the graph of f prime and f double prime. So let's look at f. Where does f have a maximum? F has a maximum here at x equals 0 because f prime, and then look at what's happening at f prime. F prime is equal to 0. But f prime equaling 0 is not enough to justify a max or a min. Because look, f prime is 0 here as well. But that does not correlate to a maximum. It correlates to a minimum. So you are not allowed to say that maximums occur because f prime is equal to 0. It's because f prime changes. And then what is it changing from? It's changing from positive f prime to negative f prime. F prime is crossing the x-axis from above the x-axis to below the x-axis. So we say changes from positive to negative. And by the way, I am okay with you writing POS period to NEG period for positive to negative, but do not put positive and negative symbols. They're a lot easier to make unclear. Okay, f of x has a minimum at x equals, so let's look at where our minimum occurs. Our minimum occurs at x equals 8. And what's happening on f prime? F prime is equal to 0, but again, that's not enough. F prime is going from below the x-axis to above the x-axis. So f of x has a minimum at x equals 8 because f prime changes from negative to positive. So again, if you're justifying maxes or mins, there has to be a change on f prime. All right, where is f increasing? So f is increasing. So when does it have a positive slope? From negative infinity to 0 and from 8 to infinity. Because, and then what's happening on the graph of f prime? So over that same interval from negative infinity to 0 and from 8 to infinity, well, what do both of those intervals have in common? F prime is above the x-axis, so f prime is positive. Okay, and then f of x is decreasing from 0 to 8. Okay, and what's happening on f prime from 0 to 8? Oh, f prime is negative. It's below the x-axis. So this is pretty much, I mean, we kind of knew this already, that when f prime is increasing, that means the slope is positive. If the slope is positive, that means f prime, aka the slope function, is also positive, et cetera, et cetera. Now, points of inflection. Let's look at what happens when you have points of inflection. So points of inflection, let's find our first one. A point of inflection is when there is a change in concavity. So that looks to be right about here, okay, at x equals 6. And when I say change in concavity, what I mean is that we're changing from like kind of a negative looking parabola, concave down. It's like part of a negative parabola until you get to something that's pointed upward. So that's like a positive parabola. These are not perfect parabolas, by the way. I'm just trying to make a point. So that change occurs right here at x equals 6. So there's a point of inflection at x equals 6. And then what is happening at f double prime? F double prime at x equals 6 is changing from negative to positive. So it's because f double prime changes signs. So there has to be a change, just like maxes and mins. But the only thing is that we don't have a special word for like a point of inflection where f double prime changes from negative to positive versus positive to negative. So points of inflection are just slightly more vague. You can just say, because f double prime changes signs. Whereas a max or a min, you have to be specific that f prime changes from positive to negative or negative to positive. All right. I also notice that at this point, f prime, so let's see what happens on the f prime graph at this point. At this point on f prime, hey, f prime has a minimum. And a minimum means changes from decreasing to increasing. So when f prime has a max or a min, f double prime is going to have a point. That means f of x is going to have a point of inflection. So if f has a point of inflection, don't write POI. I almost did that. Don't write POI because people get confused. Is it point of inflection or point of intersection? Don't write POI. So point of inflection happens when f prime has a max or min, and f double prime crosses the x-axis or changes signs, right? I should have written changes signs. So if f double prime changes signs, that means f prime has a max or a min, which means f has a point of inflection. All right, now let's talk about concavity. So f of x is concave up right here from 6 to infinity. And what's happening on f double prime? Oh, f double prime is positive. I also notice that over this interval f prime, f prime isn't positive, but it is increasing, which makes sense because f double prime is the slope function of f prime. This is so bad. My husband is singing right now. I really hope you can't hear it. Okay. So f of x is concave down over negative infinity until negative 6. Because f double prime, now let's look at what's happening on f double prime. F double prime is negative. All right, now I just ignored something, and that's the fact that f double prime is actually not negative. F double prime is actually equal to 0. So I'm going to have to amend my answer. F of x is concave down from negative infinity until 0 and from 0 to 6. But at 0, there is no concavity. At 0, there is no concavity because f double prime is equal to 0. If f double prime is equal to 0, that's not concave up or concave down. So just like if I had like a line, this is not concave up or concave down. So here the slope is equal to 0 and it flattens out so much that there is no concavity. So let me amend my answer. F of x is concave down from negative infinity until 0 and from 0 to 6 because f double prime is negative. I also notice that over this interval f prime is decreasing. Okay. If f prime is decreasing, that means the slope, f double prime, is negative. And if f double prime is negative, then f is concave down. And then the last thing I want to talk about are critical points. Critical points are x values where f prime of x is equal to 0. Those are candidates for maxes and mins. Now, a candidate means it's not necessarily a maximum or a minimum. Just like the candidates for, school secretary, not just because they're running doesn't mean they're going to get it, right? So candidates for maxes and mins just means it might be a max or a min, but it might not be. So critical points, when you see like that term, critical point means that's where f prime is equal to 0. Those are candidates for maximums and minimums, but they are not necessarily a max or a min, just a candidate for a max and a min. And you know what? I'm going to amend this even further. It's where f prime is equal to 0 or undefined. Because you can have a critical point where f prime is undefined, and that could be a max or a min. So for example, let's say you have a negative absolute value function. This is a maximum even though f prime is undefined at that point. This is not a slope of 0. This is an undefined slope. So if f prime is undefined, that it is also a candidate for a max or a min.